So in this video, we are going to talk about slope of a straight line. That is, say we measure the slope of this line, and I'm using this software called Geometer's Sketchpad. It tells me that the slope of this line is 2. So we are going to see that what does this measure, slope equals 2, mean in the case of this straight line. Okay, so let's consider some points on this line. So we look at this point, for instance, say 0, 0. It's too big. Let me reduce the font size. One moment. So this is 0, 0. And let's look at this one. So the coordinates of this point are 1, 2. So what do we notice here is this, that as we move from the point 0, 0 to 1, 2, and of course the movement is in the right direction of the x-axis, so what we see is as x changes from 0 to 1, okay, what does y do? Y changes from 0 to 2. That is, for a run of 1 unit to the right, we have a rise of how many units? 2 units to be able to get back on the line. Now if we look at the coordinates of this point here, which are 2 and then what we have here 4, so we witness the same thing, that is, from here to here the change in x is positive 1, that is, we went to the right by 1 unit. Now to get back on the line, how many units do we have to rise? 2 units. Okay, so this is what this slope means. That is, slope is 2 means that for every run of 1 unit in the right hand side, we have a rise of how much, or we have to have a rise of 2 units to get back on the line. Okay, now we shall see that how do we compute the slope. I mean, here I cheated. I just had the package tell me the slope. So we will see how to compute the slope of a given non-vertical line, and I'll specify why am I asking or why I am saying non-vertical. Now say we had moved from this, say 0 to 2, that is, instead of a run of 1 unit to the right, I have a run of 2 units to the right. Now to get back on the line, I'll have to have a rise of how many? 4 units. Now you can see a run of 2 corresponds to a rise of 4, and if we look at 4 divided by 2, that is still equals 2. Okay, so what we are going to do is that we are going to define slope of a line as, so we define slope of a non-vertical line as what? Rise over run as we move from one point to another. Okay, and of course run will be considered positive in the right direction of x-axis, and rise is positive, you know, going upwards along the y-axis. So let's see some examples. So to compute the slope of a line, all that you have to do is that choose or look at the coordinates of, coordinates of 2, of course, different points on the line, okay? And so say for instance, here we choose 1, 2 and 2, 4, okay? So now, I mean, here you can see from this triangle here that from 1 to 2 the run is 1 unit to the right, and then here we are rising from 2 to 4. So the rise is what? If we just wanted to say do it arithmetically rather than visually, then that will be 4 minus 2, that is 2. All right, so one way of obtaining the slope will be that subtract the y coordinate of this point from the y coordinate of this point to get this difference as rise, and the x coordinate of this point from the x coordinate of this one to get the difference as run. And you have to be very careful that you keep the same order. All right, that is, if you choose to subtract the y coordinate of this one from this point here, then for the run you're subtracting this coordinate from this one, okay? And therefore the slope is how much? The slope is 4 minus 2 over 2 minus 1, that is 2 over 1, and that equals 2. Now we shall attempt to find the slope of this line here. So we will go ahead, let's look at this point, easy to read. All right, and then we can let's see, this is like 4, 1, okay? So what are the coordinates of this point? They are 0, negative, 2, and those of this point are 4, 1, okay? So if we look at this thing, or if we look at how much run we get from here to here, okay, that is of course 4 minus 0, that is 4, okay? I will formally write it, that is 4. And then when we go upwards to, I'm slightly off, forgive me, okay, excuse me here, okay, so let me do that here, okay, right here, and the run is how much? Here it will become, we have to be careful with the sign, 1 minus negative 2, because negative 2 is the y coordinate of this point, that is 3, so 3 is the rise corresponding to it, okay? And so what we have is the slope of this line is, the slope is 3 over 4, okay? Let me first fix this portion. I meant the slope is 3 over 4. So let's calculate the slope of this line, or I'm sorry, let's see how we can calculate the slope of any given line on which we can measure the coordinates. So what we will do is that we shall have, say we have 2 points on this line, okay, and we know that the coordinate of this point, coordinates of this point are x1, y1, and those of this point are x2, y2. Then as before, we can notice this, that this is what will give us the corresponding rise over run, okay? Let me refine my picture a little bit, okay? And so if you look at the rise here, how do you get that? You get that by subtracting y1 from y2, okay? And the corresponding run is how much, or rather the rise corresponding to a run of x2 minus x1 is what? That's y2 minus y1. Okay, so once we take y2 minus y1, so once we take y2 minus y1 over x2 minus x1, that will be slope of this line. Okay, and then as always we have to put a caution here that we cannot have x1 equals x2 in this portion. Okay, so let me show you a numerical example again. I mean, I've shown you illustrations, so just to refresh everything or just confirm everything, let's look at a numerical example. So say we have a line on which we are given coordinates of 2 points and we have to find the slope. So what we will do is let's take this point negative 2, 5 as x1, y1 and 1, negative 1 as x2, y2. Okay, and sorry about that. All right, and then we compute the slope by obtaining this quantity. Let me take it below a little. Okay, so that is we have 5 minus negative 1, which is my y2 minus y1, divided by x2 minus x1. See, I did this here. I went in an opposite manner where we have to be cautious. I didn't do anything wrong, but let's just first go the way we had in the past. I'm sorry about that. So we are going to take y2 minus y1. So I have negative 1 minus 5 divided by 1 minus, then what we got here, negative 2. So that becomes how much? Negative 6 over 1 plus 2. That is, we have negative 6 over 3. That is, negative 2 is the slope of this line. Okay, now just to show you, say I had gone ahead and remember I did 5 minus negative 1, that is, I switched my order. Then in that case I have to keep the same order for the other coordinate. That is, I have negative 2 minus 1, which will still end up becoming negative 2. All right, what will go wrong is this, that say in the event I did this. Okay, that is, say I took 5 minus negative 1 and on the other side, instead of taking 2 minus negative 1, I switched that, then this will be a wrong answer. Okay, so just keep in mind that you are entitled to label any of them in this way if you would like. That makes sure that you keep the order. Okay, so we just saw that the slope of the line connecting these 2 points is negative 2. So just for sake of curiosity, let's go ahead and plot these 2 points. So sorry, we are plotting these points. So first point is negative 2, 5. We plot it, and then the other one is 1, negative 1. Okay, so once we have these 2 points, we are going to draw a straight line through these points, and this is a line with negative slope, and the slope as we had calculated, let's measure it again according to this. Slope is how much? The slope is negative 2, and you can see the see a difference between a line that we had with positive slope before and now we have a line with a negative slope. Okay.